Alright, so finishing the final review, what are the solutions to 2x minus 5, x plus 1 equals 0? You have to take each factor and set them equal to 0. So you add 5, so 2x equals 5, divide by 2, so x equals 5 halves. Here, subtract 1, so x equals negative 1. The table of values for the quadratic function g is shown at the right. State all of the values, so all of the solutions to where g of x equals 20. That 20 is outside of parentheses, so it is your y value. So you come over here and look to where we see 20 in the y. Well, there's one at 7. But because this is a quadratic, we know it probably has a pair. This goes with this. This goes with this. 20 goes with, well, you would say what comes before negative 3, negative 4, but look how these are changing. This is going by 2, by 2, by 2, by 2, by 2. So this is actually negative 5 would go with our 20. So 7 and negative 5 are all of those solutions. What are the values of x when x squared minus 2x minus 8 equals negative 8? So we're going to type it in our calculator. X squared minus 2x minus 8, where it equals 8. Second graph. Well, I've got fractions. So I'm in the second window. Let's go to 0. That's a negative 8. It's going to be somewhere in between there. Oh, it's a negative 8. I'm silly. Where does it equal negative 8? So it's happening at 0, at x equals 0, and x equals 2. Now, you could also find the answer by factoring. You would have to set it equal to 0 first, so plus 8 plus 8. So x squared minus 2x equals 0. Well, I don't have a trinomial, so I don't need the box. I can take an x out of both of those. Divide by x, divide by x. So x minus 2 is what's left. And then you set each of the factors equal to 0. So x equals 0, because that's one of the factors. And then x minus 2 equals 0. Add 2. So x equals 2. Same thing we saw on the calculator. Here, with our exponent laws, okay, you're going to use PEMDAS to help us remember our rules. These are our exponent laws. When it's parentheses, you multiply the exponents. So here, this is raised to a power. So 5 times 2 is 10, x to the 10th. When you multiply, you add the exponents. So here, x2 and x6, we add to give us x8. Anything to the 0 power equals 1. That's just one of our rules. When you divide, you subtract the exponents. Notice I say the exponents. 10 divided by 5 is just 2. And if I subtract the exponents, 5 minus 3 gives me a square, x squared. Which of the following expressions is equal to 4? Okay, you can type these in your calculator. Go to your home screen because there's no x's. 8 caret. Just make sure you put it in parentheses. 1 divided by 2. This equals 2.83. So that's not right. B. 16 caret 1 divided by 2. Oops, that's not a 2. Enter. 4. This one. Anything to the 0 power is 1. It's not that one. So the answer is B. Simplify. When we're simplifying the radicals, you've got to break it into your factors. So we've got 36 and 10, just because I see that 0, so I want to pull out the 10. Okay, 10 can break into 2 and 5. 36 can break into 6 and 6. And you can stop there because we have twins. So there's some twins. One gets shot, one breaks out. And who's left in jail? 2 and 5, so 2 times 5 is 10. We could check our answer. So the square root of 360 is 18.97, so approximately 18.97. So let's check our answer. 6, the square root of 10, 18.97. So yes, we did it correctly. Which of the following expressions is not equivalent? Okay, so 48 can break into 4 and 12. Okay, 12 breaks into 4 and 3. Ooh, there's twins. So 4 gets out, 3's left in jail, so that one is. Okay, 6 square root 8. Let's see. No, that's not going to be the same. There's no way to get an 8. It's got to be that one. But if I was to check 4 times 4, 16 times 3. Ooh, you can't even see that. I apologize. So 16 times 3. So this is the square root of 48. So that's the exact same number. So that one is equivalent. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 3 is 48. So that one is equivalent. Which of the following expressions is equal to a to the 5/3? Think of your tree, right? So the power source is on the top and the roots are on the bottom. So the root is the 3, so it needs to be the 3rd root, and the power is the 5, so the 5th power. So 3rd root, 5th power, A. An exponential function contains ordered pairs as shown in the table right. What is the rate of growth? To find your rate, you take y2 divided by y1. That's just our rule to find rate. So the y2 is 60, the y1 is 15, and that gives you 4. So let's see, does that work? 15 times 4? Yep. 60 times 4 is 240. 240 times 4 is 960. 960 times 4 is 3,840. So yes, your rate is 4. The table of values at the right shows some ordered pairs from an exponential function. What is the value of, you can't even see it. What is the value of f of 5? So 5 is the x because it's inside the parentheses. Remember your little arm motions. So I'm looking for where x is 5. 0, 1, 2, 3. So there would be a 4 and then there would be a 5. And this is what I want right here. Since it's exponential, that tells us it's multiplying by something, which we could use our formula for rate, y2 divided by y1, which is 10 divided by 5, 2. So each time you're multiplying by 2. 5 times 2 is 10. 10 times 2 is 20. 40 times 2 is 80. 80 times 2 is 160. So your answer is 160. What is the asymptote of the function graphed to the right? Okay, the asymptote is always the same for our exponential functions that we've done. It's always the x-axis, which is the line y equals 0. And remember, an asymptote is the invisible line that it cannot touch. Alright, a population of 1,200 rabbits, so this is the starting value, increases by 2.5%. So to change a percent to a decimal, you go 1, 2, so it's 0.025, and it's increasing from 1. At the end of 5 years, there'll be approximately 1,358 rabbits in the population. Write the function that can be used to determine the number of rabbits y in the population at the end of t years. So y equals, it starts at 1,200, the rate is 1 plus 0.025 to the t. Because it's increasing, the number's got to be greater than 1, so you start at 1, add that percent as a decimal. Alright, use the sequence. Each term is, how is it changing? Well, no offense, 128 to 2, that tells me it's probably going to be a geometric sequence. So I need to find that rate, which you take y2 divided by y1, right? So my y2 is 32 divided by 128. So if I go on my calculator, 32 divided by 128, math, enter, enter. So each term is 1/4, starting with 128. Write the function that describes the sequence. So t sub n, it starts at 1024, and I got to find that rate. So y2 divided by y1, so that's 1024 divided by 128. Let's see what that equals. 1024 divided by 128. What? Oh, I did it backwards. Y2 is 128 divided by 1024. I'm so sorry, guys. It's the end of the day. So 128 divided by 1024, math, enter, enter, is 1/8. So my rate is 1/8. So it starts at 1024 times 1/8 to the n minus 1, because it's a sequence. So it always has that n minus 1. Now, you want to know how I knew that 8 wasn't the right answer? Is this getting larger or smaller? It's getting smaller, so I knew my rate had to be less than 1. So I was really confused when I got 8, and that's how I knew that I had messed up somewhere. And I switched up my y values. Alright guys, so make sure that you have all of this written down so you can turn it in and get those 10 points added on your test.